Code for my bank card is a 4-digit integer. No digit is 0. The first digit is twice the third digit. So I called the third digit A, and then the first digit's going to be 2A. The fourth digit is 3 times the second digit. So I called the second digit B, and then the fourth digit is 3B. Now you could note at the start that B is going to have to be less than or equal to 3, and A is going to have to be less than or equal to 4. I didn't actually do that. I just kind of solved and then kind of, if if 2A and 3B went above 10 or 10 or more, then I rejected them. But you'll see in a second how I did that. So, but then also told one other piece of information that the 4-digit integer is a multiple of 9. Right, so that means a number is a multiple of 9 if its digit sum is also a multiple of 9. For example, 729, that's actually 9 cubed. If you add the digits up, you get 18. Because this number is 18 is divisible by 9, then the original one is as well. So what this means is that 2A plus B plus A plus 3B is a multiple of 9. And that means that 3A plus 4B, well, we've got a few options. It could equal 9. It could equal 18. It could equal 27. Although to be fair, because these have to be in place, b less than or equal to 3 and a less than or equal to 4, immediately the left-hand side is going to have to be less than or equal to 9 plus 16, which is 25. So I can reject this one, and I can also reject 36. If you don't see that, then with the process I'm about to give you, it would still work. And what I've done is turned it into a couple of Diophantine equations. I'm just going to deal with them one by one. So this one up here, I can divide through by any common factors, but well, no, there's no common factor between all the terms, but there is a common factor of 3 between two of the terms. So A plus 4 over 3B will equal 3 in this case. That means B has to be a multiple of 3. But that would mean that A is then minus 1. So we can reject that one. That just leaves this one. So now again, divide through by 3, a plus 4 over 3b, this time would equal 6. B can again equal 3. It can't equal 0, remember. If it is equal to 6, then it would become too big. And if it's equal to 3, then a is equal to 2. And that one works. So that is our solution. If we put it back in, then we get 8, sorry, not 8, 4, 3, 2, 9. That is the only possible solution. Let me just say, if you didn't reject that other one straight away, then we could do the same thing. A plus 4 over 3b equals 9. We could again go with b equals 3, and then a would equal 5. But then 2a would equal 10, and that's not a single digit, we would reject it. Or we could go with b equals 6, and a equals then 1. But then 3b would equal 18, and we reject that one. So the mark scheme does it slightly differently, and I think the official video solutions do, but I quite like this approach, so well done.